Hey scientists, Mr. Oeming's here, and today we're going to be measuring metric volume of liquids using two different tools. So let's get to it!
Alright, the first tools we're going to look at are beakers. We've seen them before, but we haven't used them too much. In order to measure with a beaker correctly, you have to look at the side and see the numbers that are listed on the sides. These are called graduations, like in a graduated cylinder, but they're much, much larger. These containers hold a lot more liquid than most graduated cylinders, but they're not very accurate. So if I look at this, I'm going to see two different sets. You're going to notice that this set goes from larger to smaller as it goes up. This set here goes from smaller up to larger. This is the set we want, going from smaller to larger. If you look at the color of the water I put in, as I get down on the edge and look very closely, we can see going up this side, the graduations go from 100 to 200, and that, of course, would be milliliters, like we've always measured. This one over here is a smaller beaker, and you're going to see that the measurement goes to a graduation in between the 100 and the 150. On the 150, some of you can tell that graduation is easy enough to figure out. But in case you're not familiar with how to measure that, here is a formula you can use. You're going to see that there are a 150 milliliter mark here, there's a 100 here, and there are 1, 2 in between. So you count up from 1, 1, 2, that tells us how many graduations. Using a formula, you can take the top one, 150, subtract the bottom one, 100, and that gives us a total of 50. From there are two graduations. We divide that number by 2, and that tells us that each graduation is worth 25 milliliters. Because of that, that means each of these is 25. So there's 100, that would be 125, and that would be 150. That gives us a total of 125 milliliters in this beaker. Now, beakers aren't really all that accurate. They're used for much larger volumes of liquid. But we can actually measure in between by making good estimates. So let's say, for example, I were to pour some of this out, leaving me something less than the 125, but it's not exactly at the 100 milliliter mark. This is where your estimation powers come in, and you would then measure that somewhere about halfway, it looks, between the 100 and 125, and if you take 25 and divide it by 2, that gives about 112 or 113 milliliters. If you're within about 5 milliliters, I think that would be perfectly acceptable. A reasonable estimate is okay for our purposes. To measure something with a greater degree of accuracy, you need graduated cylinders. Remember, graduated cylinders have the graduations on the side. You're going to remember that this one has the same numbers, some going down from the top and the other side going up. We're going to use the numbers going up. This graduated cylinder measures with its graduations. Hopefully we can see this, but I'll identify it if it's a problem. We have 150 right here, all the way up to 200 up here. Remember the formula that I'm teaching you about how to find out what each graduation, each line going up the side is worth. We take the top number, 200, subtract the next number down, 150, and then divide that number by how many graduations there are. It just so happens there are 25 of them, and so I did the math. 200 take away 150 is 50. Divide that by 25 graduations means each graduation is worth 2 milliliters each. So every time we count up, this would be 150 milliliters. This would be 152. This would be 154, 156, 158, 160, and so on. So you can tell what the graduations are. This one, we're going to subtract a different set of numbers. We'll just pick some right here, say 40. Subtract the next one down is 35. And there are 1, 2, 3, 4, and 5 graduations inside. Once again, I've already done the math. 40, take away 35 gives us 5. Divide that by the 5 graduations, and that gives us 1 milliliter of each graduation. So again, that would be 35, 36, 37, 38, 39, and 40 milliliters. The last one uses literally single milliliters, but there are graduations in between, so there'll be fractions. So I'm just going to pick 2 numbers. It doesn't really matter where you start from. I'll pick the 8 right here by my thumb and the 7 just below that. And in between, there are, again, 1, 2, 3, 4, 5 graduations from one number to the next. The math tells us 8 take away 7, that's where my 2 numbers on the graduated cylinder, gives us 1. 1 divided by 5, if you can't do that, calculators will be available, gives us 0 and 2/10 milliliters each. So those in between would start at the 7 and then go to 7.2, 7.4, 7.6, and so on, all the way up to 8. Graduated cylinders are much more accurate than beakers and can measure, but we do have to watch out for the meniscus. Remembering that little smile, because especially in glass graduated cylinders, the water will cling or crawl up the sides, creating that smile, and you want to measure at the bottom.
Hopefully that clears up the idea of measuring liquid volume using beakers and graduated cylinders. We're going to do some hands-on practice with this, but before we do, I'll pass out your lab worksheets and let's do a little bit of guided practice to make sure we can do this accurately. Let's get to it.